Okay, everybody, good morning. Hello and welcome to the finalist presentations in the openBIM Awards 2024. The first categories that we're going to be hearing from this morning are construction for buildings and construction for infrastructure. So let's get things started. First to the stage, I would like to invite Kelvin Law, Billy Wong, Simon Lee, and Joe Lee from Hing Engineering Company Limited.
Shall we start now? Okay. Good morning, ladies and gentlemen. This is Simon Lee, Director of Kai Tak Sports Park Limited. We are deeply honored to be here today to share with you Kai Tak Sports Park, an integrated sports, cultural, and entertainment facility in Hong Kong. The entire sports park covers an area of 28 hectares. It is part of the redevelopment of the former Hong Kong International Airport in Kai Tak. It aims to serve its users and visitors, both foreign and domestic, and including the Greater Bay Area in China, with a population of about 86 million. Kai Tak Sports Park is a design, build, and operate contract, with Hing Engineering appointed as the design and build contractor. The sports park featured a 50,000 capacity main stadium, an arena hosting sports and entertainment event, together with a youth sports ground, all complemented with extensive green and open area. Without the adoption of the openBIM approach, it is almost impossible to complete this project in only 5 years. A project at this scale and complexity requires expertise and professional know-how from a team of designers, contractors, and most importantly, beamers. During the process, we have put together over 500 beamers from around the world, all working together as one team. Just for Hing themselves, at the beginning of the project, they managed to put up a beam management team of over 50, okay, and whom eventually have all required the openBIM professional certificate. These achievements encourage us to make further steps as we move on and bring our openBIM strategy in future projects to yet another level. Now I turn over to Billy.
Thank you, Simon. So, hi, everyone. I'm Billy from Hing Construction. So for this project, we have many modularized parts in the interactive sports park. Start from the roof to the ground, we have a retractable roof system and the facade lighting system to brightening the Victoria Harbour. And the retractable roof system also can accommodate different weather conditions. And besides, we also have a mechanized seating system and the lay and pay turf to accommodate different activity and the event. And in openBIM, actually, we did a lot of openBIM in this project, and today we were going to focus 6 topics, and Joe and Kelvin were going to explain more in detail. So first of all, everything starts from the ground. We have enabled AI to help us to speed up the piling sequence, also using Sorby to automate the statutory compliance checking, DFMA steel structure, that's your left-hand side. And from your right-hand side, from architecture perspective, we also use AI to help us speed up the wall fixture coordination and joint generation. Also, the facade system also using DFMA concept to optimize the design. And last but not least, the digital twin, it helps us using digital twin to do the site verification to help us make the works do faster and smarter. And this is our software ecosystem. Today, we are in construction category, so we'll focus on construction parts. And in this project, actually, we have 7,000 piles in half. We have to finish in half years. And in this congested time frame, and we have to make sure all things make it on time. At that moment, almost nearly all the piling machine come to the site to secure our project. And the deepest pile is over 100 meter depth. By utilizing IFC standard data structure and with the facilitated AI, we customize by ourselves, and it helped us speed up the total piling sequence by 90 days. And this is the before and after results. And let me pass the mic to Joe.
Yeah, thank you, Billy. My name is Jolie. As mentioned by Billy, in the openBIM implementation summary, we have adopted digital methods from foundation to superstructure, focusing openBIM in fabrication. Selecting capable subcontractor with digital processes is essential for enhancing productivity and safety. We utilize DFMA for our spot part megatruss construction, which allow for details enhancement through BIM. Frequent data exchange occurred between consultants and manufacturers. We conduct simulation and quality check during installation extensively using laser scanning to ensure the accuracy and facilitate open data conversion. Regarding DFMA, one of the big challenges is managing and monitoring the logistic and manufacturing data schedule. We assign the unique code for each facade panel from day one. In terms of monitoring methodology, only open data format approach enable all dynamic data to go through the entire process. This approach aims to achieve an intelligent reporting system and accomplish the just-in-time strategies. Furthermore, we established a BIM cave for the project, which has significantly changed the mindset of many of our colleagues, including frontline staff, designer, consultants, and operator. Feedback from them consistently indicate that this marks a significant step forward and enable all stakeholders to utilize BIM across various channels. Clearly, the entire process relies on openBIM approach. You can see the data and file conversion flow through the openBIM in the bottom, in the flow chart at the bottom. So next, coming Kelvin will show the automation application.
Thank you, Joe. So other than the, this is Kelvin, other than the construction technology Joe just mentioned, we also leverage the information model onto automation tasks. Under a compact time frame, design and construction detailing must conduct concurrently. It's crucial for each detailing iteration can both fulfill requirements and be constructible. With quality data in IFC model, over 30 crucial rule sets were developed to facilitate statutory compliance checks. This example shows a smoke detector is not found near the exit door, which is a local statutory compliance requirement. 90,000 elements in 3,000 rooms are checked within 3 days. This results in 20 times in productivity improvements and safeguard code compliance check along the project lifecycle. Cai Spot Park is not a typical project, with rooms mostly not repeatable. The sports complex has extensive IT infrastructure design. Huge amounts of wall fixtures need to be coordinated aesthetically and for constructability. With 1 week of proof of concept, the general coordination of over 100,000 wall fixtures in 5,000 rooms is completed in 6 months through AI. This is 12 months were saved, and it's equivalent to 3 times of productivity improvement. Through quality project data in open formats, innovation is catalyzed, and we were able to think deeper and further to achieve more. Other than the data openness, frontline and back office team are also seamlessly connected in this mega project. Through IFC-compatible lightweight mobile platforms, the team can share progress and information, facilitating paperless progress monitoring and inspection, as well as works and placement certification. The extensive availability of open data also enables the team to set up platform for data-centric analytics and management portal. From various sources, data are extracted, transformed, and loaded to provide information for prompt decision-making processes, which include progress monitoring, environmental monitoring, and safety management. Through Esri ArcGIS, this data can be further augmented with IFC models, helping the team to be comprehensive in site management in terms of progress, safety, and sustainability. This is an overview of some key processes along the entire project timeline, until where we are now at the final commissioning stage. With open formats such as IFC and BCF formats, the team's construction expertise has been utilized efficiently in this mega-scale project, such that this permits information exchange between processes to improve project efficiency, from design, procure, assemble, and to the current imminent operation stage. In this project, which is extensive in facade and steel system, which is equivalent to 3 times Eiffel Tower's steel tonnage, the project efficiencies has been enhanced via a more seamless collaboration amongst over 140 parties that are connected via the BIM-based BCF format. This has helped us in various project execution metrics, such as 20 times in productivity improvements, 12 months reduction in manual coordination time for wall fixtures, and a 6.3% reduction in steel tonnage of the design. In the journey so far we had gone through for Cai Sport Park project, for a project of this scale and special nature, the team has learned from scratch the relationship of data, assets, and systems that are unique from other types of common developments. In addition to today's opportunity, we will continue to gather and share our lesson learned to the openBIM community for the coming developments of the next generation of IFC. I will pass the time to Billy to share our common visions.
So after this lesson learned project, we have a dream. So let me make a short summary. So we think that openBIM should be mandatory, and right at the beginning, the client should utilize IDS and BSDD. It's just like the Rugby 7 match. We should have a policy. The IDS and BSDD set up the rule at the game at the beginning, and we should have a process and strategy by utilizing IFC and BCF. And last but not least, people. People is very important. We should get well trained before they start this rugby match. So make sure get a professional certificate. And the most important thing is we should have a platform. Open CDE platform will help us centralize all information together. It's just like the rugby court. So I would like to take this chance to thank for international chapter leaders come to visit our Cai Sport Park in June, and looking forward to see you all next year for the Kobe concert and the Rugby 7. Thank you.
Thank you very much. If I could ask you to just come and take your seats. And next up, we are going to hear from Thomas Crossley from Kier Construction. Please take to the stage, Thomas. Thank you. This is the second of the 2 finalists in this category. When we finished hearing from Thomas, you could remain on the stage, Thomas, and I'll invite the team from Hipping back up to the stage. Thank you. Okay. When you're ready, Thomas.
Hi, good morning, everybody. So I'm going to talk to you about Kier Construction and how we've optimized super prism delivery in the UK. So just a short, brief intro about me. There's me in my smiling hat. So I have 15 years experience in the construction industry, and I work for a company called Kier. It's almost 100 years old. and we specialise in all sorts of things, from universities to prisons to railways. And so our current prison is located in York in the UK. It's a £400 million prison based in Yorkshire. It's due to open very soon. So a PC date is in 4 months' time. It's a Category C prison, and it's going to contain enough spaces to house 1,500 prisoners. It's the first prison to run solely on electricity, so there's no gas involved, so which is pretty cool. And pretty much every building has solar panels on the roof. How it's been built is with model methods of construction, and all our sort of digital workflows are based around openBIM. So a little bit about the project. So the project has a mandated UK BIM requirement, and that is the BS 1192 standard from quite a few years ago now. The MOJ is transitioning to ISO 19650, and this is one of the last projects to be instructed that old set of requirements. However, that hasn't stopped us from literally pushing as far as we can with digital activities. So they have a very well-established AIR, which is all based around openBIM, and it's pretty extensive. I mean, we're talking millions of data to collect on site, million pieces of data, and we're currently building 13 assets, which includes site infrastructure. So that's 6 ancillary buildings for visitation, health, work, education, and training, and 6 house blocks for the accommodation. So the whole ethos of the site is to rehabilitate offenders and to make sure that when they leave, they have the necessary skills in place to be able to go back into the community. So the sort of digital process that we've implemented, so we have a accommodator environment, and that's aligned to BS 1192. We have a cloud-based MIDP planning system, which has automated reporting from the accommodator environment, so we can track all our deliverables. We have a cloud-based information model, so we get all of the models synced into the cloud every 2 weeks, which is pretty cool. So that's probably a first for our construction company. And we've got automated coordination checks in place as well. We also have a quality management platform, which is supported by IFC, and we use that out in the field to have a paperless site. And we've got automated IFC validation and quality reporting with Power BI. In addition to that, we have 4D, and we've also managed to track all our DFMA components with a digital twin as well. And finally, after we've collected all that data, we are producing COBE. So some information about our BIM information. So this is our model breakdown. So we have approximately 205 models. It might change because we've got handover in 4 months and we've got a few tweaks left to do. We have 13 overall asset models, and you can see them there, each with their little red tag against them. Currently in our project information model, we have over 14 million lines of property data. We have 1.5 million classification codes. So that's Uniclass, NRM, SFG20. SFG20 is the maintenance regime classification system that's used in the UK. We've exchanged over 234 BCF files. We've resolved about 5,730 clashes. Now, when we add our whole data requirement, which includes all sorts of things within the IFC file, so including layers, classification codes, properties, attributes, we're looking at 34 million lines of data that we're checking every 2 weeks. So that's quite a challenge, and to do that in Solibri is very difficult, particularly when we are a team of 3 people. So what we've done is we've built a data quality pipeline. So we've been able to ingest the IFCs, and we've been able to validate them automatically. So the only reason why we've been able to do this is because the MOJ, the UK MOJ, the Ministry of Justice, they've mandated openBIM for quite a while now. And this is our second attempt at a prison, and we've learned quite a lot. And that's the reason why the title of the original slide deck is called Optimizing Super Prison Delivery. So what we've been able to do, because we have openBIM on the project, is we've been able to improve communication across the board. So we have access to information from all sorts of applications, and I'll show you the software map in a minute. We've reduced interoperability barriers between those platforms because we have an open environment to work with. We've streamlined our 4D planning process. We've enabled our offsite tracking. Obviously, we've got quality management, and we're using those models out in the field, as you can see in that nice little picture. And we were able to produce code. So what does that pipeline look like? So we've used a combination of Python, IFC OpenShell, and Power BI. And we've effectively built an automated pipeline to be able to check, validate, and clearly communicate the client's data requirements. This has simplified, sped up, and automated the whole check-in process. And we've done all this before the development of IDS was a thing. So it's sort of, we thought we were a step ahead of the game, and as usual, we're not. So the great thing about this is that we've been able to take the IFC data and we've been able to visualize it in Power BI. We've been able to educate, upskill our whole project team. That's improved the knowledge of IFC quite dramatically. And because it's in such a simple format, easy to use format, which I'll show you in a second, it's really boosted our ability to deliver this data. And it's also starting to give us the confidence and the assurance that we can use it so it can be relied upon within our other applications. Because part of the challenge we've always had is the I in BIM, and people not believing or not trusting it. And therefore, this process that we've developed really helps that. So this is our software ecosystem. So we have our architects, engineers, specialists, subcontractors. They all produce IFC models. They all go into the common data environment. They have to make sure that they've put that in their information delivery plans first. So making sure we're completing our plans versus our actual. And then effectively what happens is those IFC models get ingested into our pipeline. That gets checked against our information requirements. It goes into Power BI, we get to see those results, and then effectively we can say, right, that's great. And if we pass that information, then it goes into our other platforms. So we're using Celibri and Revits2 for a combination of coordination and collaboration. We're using Asta Power Program for our project programs. We're using Deluxe quality application. We're using WideAlbia to track our components. And we've got Glider BIM at the end to collate all our data from our IFCs and enrich the files. And we wouldn't be able to do any of this without IFC at the center of it. So unfortunately, because it's a live prison, I can't really show you any of the live sort of application or any of the data that's in there. So some of the stuff in here is blurred out, unfortunately. But effectively what we've got is a report that's in quite a simplistic view to begin with. And then what we can do is we can drill into individual models or disciplines or particular parts of a model file, and we can see a summary of the data quality. Everything here is presented in plain language. So if there is a problem, it tells you what the problem is. So for instance, if it's a duplicate value, it will just say it's a duplicate. What we're trying to do here is dispel the issues that we have with complexity around rule sets and general BIM, and just get to the root of the problem. So once we do that, we can then drill into the data. We can then report on that, and that gives people sort of a punch list to to fix. So sort of our key outcomes from the project. So overall, it's reduced complexity, like I've said. We've got better reporting upstream. So I can now report to my boss, have we got a good or bad model? I can say we've got a really good model, we've got a really bad model. We can also report downstream to the model suppliers and tell them precisely what's wrong. This has sped up the whole process. It's fully automated. It's literally 2 buttons to press. So we've removed the need for manual reporting. It's all hosted online, so it's easily accessible. within our security requirements of SharePoint, obviously. It's boosted the overall understanding of IFC. Basically, yeah, we've removed misunderstanding from the project because we're all parties on the same page, because we're all singing from the same hymn sheet. So some of the things that we've been able to do, and I've got 3 minutes, so I'm going to rattle through these now. So because we have high quality data in our models, the IFC entities, predefined types and classification codes, we've been able to implement a really cool check-in system where we can check certain objects against other certain objects. And when we pick that up, we can share that via BCF into Revitsu. We've got almost 250 active users in the platform, and like I've said, we've cleared off 5,000 clashes. So our Wynomia component tracking, which I think is very, very clever tech. So what we've been able to do is we've been able to connect Wynomia, which is a DFMA platform, to our accommodation environment, to Dalux, and what it does is it tracks the components from manufacture to install. So, and it also tracks design as well. So here in this little card at the top, you can see if the design is rejected, accepted, and also whether or not it's been installed on site, and it's all connected via nice integrations. Now, we wouldn't have been able to do this without IFC because the information checks that we have in place allows us to validate to make sure we've got uniqueness in every single one of those precast panels. If we didn't have that, we would really struggle. So another issue, another problem solved here is that because, again, we've got high quality models with a lot of spatial data in, we've been able to streamline our assets and link it back to program using the unique identifiers that have been specified by the client. We've done this with Asta. It's still quite a manual process, but we've done some cool stuff by linking the programs into Microsoft Streams and sharing it across the project team. So again, Dalux on the field. This is a really cool app. Again, the benefit from the IFC here is that Dalux can use the spatial data from the IFC models, and we've structured all of our quality issue management around that spatial data. So when we pull off the data via an API, we can then check and see where all the issues are. And then because everything is work packaged up, we can then track who's the worst offender in terms of quality. Finally, so the last slide, so I've got 1 minute left, so I'll try and see if I can wrap this up really quickly. So we have GliderBIM as a platform. It's a digital handover platform that allows us to enrich the data within our IFCs. So throughout the whole project, we've been progressively collecting the IFCs, checking to make sure they fit the schema that we've been issued. And once we are sure that they fit the schema, we get all those entities work packaged, we get them split up, we get them divided, we get them sent out to trades. Trades then will come in to enter all of the serial numbers, all the warranties, all the barcodes, all that sort of good stuff that we find on site. And then we collect that via the GliderBIM platform, which then allows us to enrich the IFC files and output the data to a really high standard, and then produce a COBie document, which we issue to the client. Key participants, so we've got Kier, Ministry of Justice, Pick Everard Curtains, MZA, Protect, Witco, TS Booker and Game, all of which hadn't used IFC before and are very good now. Thank you.
Thank you, Thomas. So Hiping, if you could rejoin the stage. That was the beeping of the timer if you do run out of time. You didn't, Thomas, but just to warn everyone else.
It's very difficult to sum 2.5 years in 20 minutes.
So I'm over here now with the jury and going to give them the opportunity to ask a couple of questions. We don't have much time, so we'll get to it.
Yeah. Thanks for the presentation. So for team one, my question is, what would you done without IFC? Because we saw the use of IFC was very deep in your project, and what would you do without IFC? What is the situation for your project?
There should be a microphone in the lectern there.
So without IFC, what will be the situation, right? So I think one of the reasons is the proprietary format that without IFC, and actually our supplier and contractor is quite variable in their devotes or their commitments in BIM or in open BIM technology. So by doing an open and non-proprietary format, we can actually cater a wide range of specialists and subcontractors to join us in the collaboration. So without open BIM, it will be quite hard to collaborate in a wide range of technologies.
One more thing is, like, are we using the AI to help us to speed up the work? Data should be standardized. IFC help us standardize all data to let us have a common protocol to speed up our development process. So I think IFC is the way to go.
Thank you. Do we have a question for Thomas? Or Ken, do you have a question?
Yes. Thank you for the great presentation. And then it was quite amazing to create the software ecosystem based on IFC. And I found that at the center of the ecosystem map, there's the IFC OpenShell API and Python. And then you extract the IFC data and then divide those two, the several CDE. But it's very new, but I guess it will be the universal process. But how do you collaborate with all those many CDs companies and then the system integrator? That's the question.
Yeah, so it's quite a good one. I think most of the platforms that this is definitely working. Yeah, most of the platforms that we have, we pre-selected to make sure they had really good compatibility with IFC, because we have such a strong client requirement around IFC. It's quite a challenge to ensure that data quality is high across all these different platforms, and that's why we implemented the data pipeline. So we have a minimum requirement data that we need to fit within the platform, within each of those platforms, to be able to do each of the digital activities that are linked to each platform. So for instance, if we had clash detection, we need to know what entities they are, we need to know what classification codes they are, so therefore we can push them through into our Solibri rules. Revitsu is quite a challenge with IFCs at the minute, we find, but it's a very excellent collaboration platform. It puts issues together simply for our contractors and our sort of supply team to be able to use. So yeah, so I'd say the IFC is not necessarily used, it's more of a visualization in that platform, but Solibri does all the hard work there. Dalux is brilliant at IFCs. Obviously, it's a Scandinavian product, I believe. So they sort of put that at the center of all things, which is really useful. The component tracking is pretty much just a small software company based in Australia, and they work with us with the IFCs to be able to link into their platform. And yeah, it was really easy. I mean, it's just having good relationships generally with people and the software companies that we use. So yeah, I think that's sums up really good relationships.
Thanks, Thomas. Okay, could probably do a short question if there's a quick one.
Yeah. A quick one, also to your project. Your team was very small, 3-person. It's compact. Yeah. What would be with 10, 20 people for the BIM management? What would change? It's an advantage or disadvantage?
Can you repeat the question? Sorry.
Yeah. 3 people for the BIM management in your team. Yeah. It's a compact team. And what would be the difference if the team is bigger?
We probably wouldn't have invented a data pipeline to solve the problem. We potentially wouldn't have used the IFC as much. I think because IFC is so powerful in that consistent format, we've been able to run our checks and automate, getting attacked. So I think we wouldn't have innovated as much, basically. I think we wouldn't have used the IFC as much as we did, because generally my small team is problem solvers, and when we get given a problem, we like to solve it. So yeah, sorry, I can't answer any better than that, but hopefully that makes sense.
Thank you. All right, we are at time. I don't think we'll have any time for any more questions, so we'll wrap it up there. Thank you both teams there for your presentations.
Thank you.
So now we will move on to the next category, which is construction for infrastructure. And the first presentation is going to be from Guangdong Airport Authority. I would like to invite Lei Ma and Yang Yan to the stage. Thank you.
Can we start now? Okay. Ladies and gentlemen, good morning. I'm Yang. Here's my colleague, Lei. Today, we are extremely honored to be here for presentation. Both of us are from Guangdong Airport Authority. Now, we would like to share our achievements in intelligent construction and openBIM practice. Guangdong Baiyun Airport, one of the 3 major hub airports in China, ranked first in the passenger traffic in China for the last 4 years and globally in 2020. Its third phase expansion project, with about 7 billion euro investment, includes 2 4E-class runways and the largest single terminal building, making it China's largest ongoing airport project. As this is a large-scale and complicated linear and vertical airport project, we have to deal with collaboration issues among a diverse range of engineering types and numerous stakeholders. By identifying key challenges, we adopted openBIM standards and formulated a tailored solution. IFC for data exchange across different softwares, BSDD for standardized terms, IDS for consistency of information requirements, BCF for easier communication and issues trackings, and OpenCDE as a single source of truth. By in-depth study of openBIM standards, international standards, and industry standards, we established our project's standard ecosystem. It integrates various requirements from project management, data exchange, and execution level, providing a strong guidelines for decision-making. Here's the responsibility matrix of the project, followed by ISO 19650, which play a key role in project management, not only by decision-making, but also helps preventing overlap and supporting accountability. The following diagram illustrates the project's software ecosystem. In the detailed design module, design software collaborates based on IFC formats, extend attributes through BSDD. After review works with BCF, the model will be published and stored as a single source of truth in CDE, ensuring data accuracy and consistency. It also demonstrates how data exchange in fabrication and construction phase, all data will flow through the core CDE, generates a rich archive of data assets, ensuring data support for future project operation and maintenance. In project's openBIM process map, the entire workflow of the project starts from the responsibility of each participant. The core of model-based construction management is to focus on 3 main applications: progress management, quality management, and payment management. Technical applications developed for openBIM involve the management of data and eliminate disconnected workflows. We established a construction management platform which serves as CDE in this project. For the following part of the presentation, construction management platform will be referred to as CMP. IFC used as the intermediary data format to manage and store model files in CMP. We also adopt IFC validation service to improving data accuracy in this project. Since the working language for project implementation in China is Chinese, and due to the confidentiality requirements, we could not directly use BSDD. However, we follow the BSDD technical framework to establish a local data dictionary. Based on the objectives and the scope outlined in the BEP, we sought out information requirements from project's whole life cycle. For the general data which already published on BSDD, we translated and adopted. For personalized data, which needs extension, we extend the requirements to formal data templates. Currently, we have already completed over 5,000 data templates. Here's a list of use cases in construction phase of the project. Today, we are going to share some special ones. Long suspended flight construction must be one of our core targets, as this is an expansion project, and we have a terminal project under across 3 operating runways. So how to ensure the normal operation of Terminal 1 and Terminal 2 is crucial. Models from different vendors were integrated with IFC files to form a simulation model. Combining shared tunneling technology, construction schedule, and real-time flight information, we developed non-stop flight construction plan. Relevant data was published and exchanged on the CMP, enabling the following execution and supervision works. Additionally, electronic fences based on BIM and GIS data were adopted in CMP to replace physical barriers in sensitive zones. Use case 6 is an innovative practice of this project. For most cases in China, construction is still carried out in a traditional way. Highly reliant on construction drawings, which makes the BIM model just a 3D visualization tool. It is crucial to change this situation by finding a convenient and efficient way to connect construction works and model units. Therefore, we established this use case, where we match a group of model units with a real object in inspection nodes, which we name it inspection units, to realize model-based construction and acceptance. To do so, we adopt ISO 19650 management approach for model breakdown planning, openBIM workflow for projects data delivery. Additionally, inspection units should have flexibility to adapt to the ever-changing conditions of construction sites. Hence, we extract relevant data and deliver the requirements to CMP via IDS. By flexibly combining and modifying related data in CMP, inspection units become more practical in real cases. In this process, IDS provides precise description of information requirements, improving the alignment of information production. To realize inspection unit-based construction management, it is necessary to predefine specific execution requirements in use cases. The execution criteria and rules are mainly from professional standards and have strong correspondence with relevant data in inspection units. By establishing effective mapping relationship of them within IFC schema, the efficiency of highly repeated works in quality inspection and quantity takeoff has been significantly enhanced. For execution of progress management, managers can use 316-degree holographic images to match IFC models in the CMP to assist in construction progress management. IDS extracts the engineering object data that match the on-site construction conditions and continuously updates the data on the CMP, enabling the real-time alerts and reminders. Impressively, most construction works were completed on time or even ahead of schedule. In terms of the quality management, by scanning QR codes to match the real object and the model, relevant model attributes and acceptance requirements can be quickly obtained. The AR tool can also conduct simple measurement works, and the collected data will serve as an important basis for acceptance materials. For more precise Once the inspection units from quality management pass acceptance, the payment request can be initiated. The quantity takeoff software will generate the total price of each inspection units by assessing model quality, loss factor, and unit price. Then publish it on CMP to assist payment management. All payment details can be tracked and finally summarized in the payment management dashboard. In this project, a large number of intelligent devices are used for construction, with the most notable benefits come from automatic plastering robots, with higher efficiency and better quality than manual works. To achieve more efficient intelligent device management, we seamlessly integrated GIS with BIM. Using FC geometric data, we planned optimal trajectories for intelligent equipment, while GIS enabled real-time positioning and full-site operational monitoring. This not only gave us full control over the equipment, but also made the site management smarter. Here are the other use cases. By comprehensively using openBIM, this project has achieved remarkable benefits. By adopting IFC, software collaboration numbers increased from 10 to 55, especially for some Chinese native software used in this project, which was established by some small-sized software vendors. This open and vendor-neutral resources contribute to the software diversity in the build asset industry. Based on a more efficient and precise model-based collaboration methods provided by BCF, the coordination willingness of the model authors has significantly increased. Over 27,000 markup files has been exchanged, enabling designers to optimize a large number of design issues within a very short design cycle, thereby significantly enhancing the quality of decision outcomes. The comprehensive benefits are also quite outstanding, with notable achievements in saving investments, optimizing design, improving space utilization, enhancing measurement accuracy, and using smart devices to increase work efficiency. Then I will hand over to Mr. Ma.
In 2020, we organized over 40 key engineers to obtain PCERT certification. In 2022, we collaborate with BIC, CRBIM, and CCCC to take part in CNBSDD project. In 2023, we invited buildingSMART International Chairman Ian and COO Kelly to GA for get our openBIM. In 2024, we attend the buildingSMART International Summit, Spring Summit, and take a presentation in airport domain. Now we are proud to become the 10th SAC member. Looking ahead, we are rely on the airport working group to jointly develop IFC standards, implement BSDD, and support 9 strategic projects. Our goal is not only to promote the advance of openBIM concept within China, but also to share China's success experience in BIM and intelligence construction with the world. Look at the picture. So, fostering greater collaborations and strengthening our global connections. Thank you very much for listening. That's all.
That's great. Thank you both for that presentation. And we will move swiftly on to PORR Romania. Could I invite Dan and Irina to the stage? Thank you.
Hello everyone, I'm Irina Dumitru and I'm thrilled to represent PORR Romania today. Together with my colleague Dan Vlăsceanu, we will present the innovative work we have implemented in one of our key infrastructure projects using openBIM.
Please try again now.
Okay, let me start by introducing our team. Alongside myself, I am joined by Dan Vlăsceanu, BIM Area Manager at PORR Romania. Our work is backed by an incredible team led by Costel Cojanu and Harald Metziger, who are supporting us from the audience. In my presentation today, we will walk you very fast through our journey. We will have a brief overview over PORR Group and PORR Romania, and followed by some key information about the project. And then my colleague Dan will talk with you about each use case one by one. PORR Group is a pioneer in the construction industry with over 150 years of experience. We are a one-stop shop for construction solution, handling everything from design, execution, and operation. Our focus is building with and for people, using the latest technologies to deliver intelligent and sustainable projects. PORR operates across 7 key home markets, including Austria, Germany, Switzerland, and Romania. And here we are represented with our entire portfolio of services. This allows us to offer comprehensive solutions from design to construction and operation in all of this country. With around 21,000 colleagues from over 90 countries, we are proud to deliver major infrastructure projects across the entire Europe. In PORR Romania, we've been involved in several large-scale infrastructure projects, and we take pride in our openBIM approach. Some of these key projects that we've delivered using openBIM includes A2 runway from Otopeni Airport, the railway from Vidra Comana, and the motorway A1, which is the subject of the today project. Now let's move on to the project that hosts our openBIM solution, the TransCarpathian Motorway, specifically the 4th section from Ticven to Curtea de Argeș. This is a critical part of Romania infrastructure. This section is part of the Pan-European Corridor 4 and has a value over 337 million euros. PORR Romania is acting as a general entrepreneur, and the project type is design and build. This project is not only about building a road, it's about how we are using openBIM principles for this project. Now I'm going to pass the stage to my colleague Dan. And thank you.
Thank you, Irina. Hello, everybody. My name is Dan, and I'm here to quickly, hopefully, finish going through all the use case we've prepared for you. Okay, so let's start. Modeling existing conditions. What we found from previous projects is that it's essential to understand the location of the future site. So that's why we did drone flights with LiDAR scanning, but also normal surveying methods like GPS and total station of the existing features on the ground, like roads, buildings, and then combine them together in Trimble Business Center, exported that newly created surface, and then through Trimble Quadri exported it as a new IFC 4x3. This will be a recurring theme with IFC 4x3. Okay, 3D coordination. Of course, we consider that in any BIM project, 3D coordination is essential. Basically, we created a comprehensive system ecosystem map which allows us to federate different models from different disciplines, but also different stages of the construction process. For our common data environment, we have chosen Trimble Connect, and this is where we federate all these models. And this allows us to have, of course, better collaboration with our colleagues on site, but also to quickly identify and see clashes that we can resolve in order to ensure a much smoother construction process. Okay, data migration. Unfortunately, from our designers, we are only getting some very basic IFC 2x3 files. Basically, all the elements there are IFC building, IFC building element proxy classes. So then we are taking these files in Blender BIM, or now called Bonsai, and mapping them to the correct classes, IFC columns, beams, whatever, but also adding properties, materials, IFC groups, and classifications using BSDD. After that, we are going a step further, and via Quadri, we are actually converting them to IFC 4x3 and adding specific IFC 4x3 elements like IFC linear placement, IFC alignments, and other custom IFC 4x3 property sets. Okay, unfortunately, we cannot be perfect. We are only human, so that's why we need to validate our data. So we are very happy that IDS actually exists, and we can check what we did in the previous stage. Basically, we have an own PORR application that's an online platform in order to create and validate the IDS files, to validate the IFC files. And after that process, we can move into more practical use cases. Let's say quantity takeoff. We can define the planned quantities here. We can get the quantities via Trimble Connect as data tables. But we also create a lot of custom Power BI dashboards. This will be a recurring theme here. So basically, we are taking the IFC and putting it into Speckle, and then through the Power BI connector, the Speckle connector, we're creating dynamic dashboards that allow us to have a much better way of filtering and analyzing our quantities and other types of data. As for the executed quantities, basically on our site, we are doing every 2 weeks photogrammetric flights. We are processing the data, generating the point clouds, the orthophoto plans, the digital terrain model, and then uploading them to a cloud platform, which also hosts our IFC files. And there we are able to calculate cut and fill volumes, material stocks, and to track the actual progress of the site. For the phase planning, so what we've done here, we took the construction schedule, the planned schedule from Primavera, exported it as a CSV, and using IFC OpenShell, we have automatically put the information from the schedule in the IFC files. But I'm talking about not custom property sets. We are actually using the correct classes. We are attributing to the IFC work schedule, IFC tasks, so on and so forth. And then we are running 4D simulations in Blender BIM Bonsai. And this allows, of course, our colleagues to have a much on-site, to have a much better understanding of what and how they are going to build the actual motorway itself. Okay. Site progress monitoring, as I said, Power BI will become a recurring thing in this presentation. So we have two dashboards here, one for monitoring the status of the bridges. So we have the IFCs of our structures. We put them again into Speckle. And at the same time, we have one Excel file that is hosted on OneDrive. And every 2 weeks, my colleagues update the Excel file and put the actual dates of the execution of the elements. And then through Power BI, we link the Excel file with the IFC, and we can see exactly what has been finished, what has been started, what is delayed, and so on and so forth. And this is presenting every month, at the end of the month, to the major management of the company to have an understanding of what's happening on site. And we also have this type of application for the tunnel. By the way, this is the first motorway tunnel that has ever been built in Romania, just as a fun fact. Okay, so this dashboard is a little bit more complicated. We have our tunnel department has developed an internal app called DigiTune, where the site managers log their shifts. So basically, at the end of every shift, they put in this application the information, the whole information about the shift. How much volume, from where to where, who was working, a lot, let's say 80 columns in Excel. Okay, so we are doing an export from that to CSV or Excel. And then through Dynamo in Civil 3D, we are taking the model of the tunnel and basically cutting the geometry exactly like they logged their shifts, and additionally attaching all of the information of that particular shift within the newly created 3D geometry. And then we can export it to IFC and bring it through Speckle to Power BI. Just as a small disclaimer here, this was the original workflow, and it worked. That's not an issue, but we found that it's easier to go directly from Dynamo to and Civil 3D to Speckle to Power BI, just to let you know. Okay, BIM to field. We have two things here. So machine control systems. We are putting our design data, the IFC files, the XMLs, the 3D lines, and the surveying benchmark network in Trimble Business Center, where we are creating the data for the machine in the machines and the specific formats, and then via Trimble Works Manager, sending them to our machines on site. And this helps a lot with precision, with, I don't know, time. You reduce a lot of time, a lot of effort. We have tested this on multiple sites. The other part of BIM to field is augmented reality. So we have a device called Trimble Site Vision, which is like a GPS that you connect your phone into. And basically, you can bring the models into real life. So because the models are hosted on Trimble Connect, you are able to go on site, load the Site Vision app, and see the model overlaid with reality. And then, of course, you can also access the attributes, the properties of the elements, but also it allows for site managers to visually confirm that what we need to build is actually built where it's supposed to be, which is, yeah. The other part, now we go into reverse mode. So we had BIM to field, now field to BIM. So what we are doing on site, we are doing laser scans and also total station measurements, and then bringing that into the BIM environment. So in Trimble Business Center, we are taking the IFC files and the point clouds and the total station measurements and doing so-called scan deviations. And from that, we get the precision. This column of the bridge has been executed on a horizontal precision of, I don't know, 5 centimeters on X and 6 on Y. And then we are taking this data and leveraging the new common property sets in IFC 4x3, like the properties for tolerance. We are adding that into Quadri to the IFC files and validating the IFC with an IDS report to ensure that they were executed within project requirements. Okay. Visualization is another, our last use case. So we are taking the IFC files in Quadri, exporting them to FBX, and then in Twinmotion, we create high resolution renders and videos, but we are going actually one step further and going also into Unreal Engine and creating actual simulations. I've tried to recreate GTA, let's say, within the model of the motorway, and it works. It's great for marketing and for shareholders to understand what's happening on site. Okay, 40 seconds. Those are the use cases. So basically I finished, but this is just a bonus 2 slides. Of course, it's about AI because everything is now about AI. Basically what we did, we managed to install IFC OpenShell within the ChatGPT environment, and this lets us now create IFC analysis, like generating reports and 4D analysis, taking advantage of the use case I said previous with the work schedules, but also it allows to, we can edit the IFC, put attributes, properties, and so on. Thank you for your attention.
Thank you, Irina and Dan. Perfectly timed. And for the third and final presentation in this category, I would like to welcome to the stage China Communication Construction Company Limited. Representing them, we have Daniel and Chaojun. It's up there.
Good morning. Good morning. This is Simon from China Harbor, the CCCC. Today I'm going to share with you the information management innovations based on openBIM for Bogotá Metro Line 1. The communication is composed of project information, key openBIM information, key outcomes, key participants, and contact information. Located in Bogotá, Colombia, this project is of 24 kilometers in length. As you can see here, all designs are integrated in our ArcGIS system. Up to now, almost 2,000 IFC models are created and exchanged, which include the depot, the urbanism, the viaduct, and the underground utilities, 16 metro stations, and 13 bus rapid transit stations. As you can see here, all different kind of geographic information are integrated, which include the orthophoto, the DEM, the point clouds, so as to guarantee so as to facilitate a better communication and also a better decision making. Multiple disciplines such as like the utilities, like the structures, MEPs, and equipment are confronted in this project, which involves multiple different kind of platforms and the softwares. And according to the timeline, you can see the design, construction, and O&M stage covers almost 28 years. Hence, the scale and the duration are the two fundamental challenges, which triggered us to think how we are going to be able to manage such quantity of information and how we are going to guarantee the information transmission across different kind of disciplines and across different kind of stages. Hence, in this project, it is quite demanding in the information requirement, information exchange, information centralization, and information connection. The good thing is, with the help of openBIM, we have been able to tackle the aforementioned challenges. Actually, 4 openBIM initiatives are adopted in our project. They are BIM, open to every software, BIM, open to every stakeholder, BIM, open to data visualization, and BIM, open to every stage. BIM, open to every software, is achieved by the BSI openBIM solutions, while the rest of the other 3 openBIM solutions are achieved by our own customized tools. As we just mentioned, BIM open to every software is achieved via our the open standards in this project, which include the GBXML file, the NANXML file, the BCF, and the IFC. More specifically, from the Revit to the design builder, the GBXML file has been used to support us to conduct the sustainability study, which include the solar radiation study, the thermal behavior study, the sunlight study. And as a linear discipline, track was designed in the Bentley Open Road Designer, and the NANXML file was extracted from the Bentley, and then further we imported into our Civil 3D. And also we may update our rail corridor based on the updated alignment. And finally, we extract the solid models from the corridors, as you can see from this kind of whole workflow. And BCF was used to support us in the, the registration, the communication, and the solve of those kind of technical issues, and across different kind of platforms include the Aconics, the ACC, and also our Levisworks. IFC are compulsory in our project, which is defined by our contract. As you can see here, IFC are used to support the communication and also the model review in the Aconics, which is used by our clients. Besides, IFC models are used as the input in the Tekla to deepen the geometry of the steel structures. For example, based on the LOG 350 IFC models, we further deepen the geometry of the steel structures by adding more, connection details. And after that, we export the IFC models so as to be supported in different kind of platforms. As being open to every stakeholder, right now, the BIM 360 and ACC are established as our CDE for all of our appointed party, facilitating the collaboration and centralizing the information. Aconics is used by our clients as it is, help us to define, to control quite a good version control. So for right now, we have almost 40 contractors from 6 countries involved in our CDE. And as you can see right now, we have so many contractors involved in our CDE, and also considering the fact this is a linear project with so many contractors and almost with a length of 24 kilometers. Hence, it is quite important to have a data connection platform. So with the help of the Revit and ACC API, a customized data connection platform has made it possible to connect the site data. And also, by doing so, we can open our BIM to all the sites. More specifically, for example, I just mentioned some data connection from the site. We can, for example, we can connect the progress data, the site progress data. Thus, we can open our BIM to our planning team for them to use it. And also, as you may know right now, we are right now under the design optimized, and also our construction stage. Hence, we are still having so many models unfrozen. Hence, it is quite important to have the up-to-date federated models so as to guarantee all of our stakeholders can always have the accessibility to the most up-to-date and integrated information. So with the help of the ACC API, we have achieved the automatic federated models, and thus we enhancing our efficiency, and more importantly, we can open our BIM to every stakeholders and also in time. This is an example of the federated models. This is one of our metros, the federated model of one of our metro stations. As you can see, 9 models are from the construction models and 85 are from the design models. But with the time goes on, we are going to replace all those old design models with new construction models. The next is about BIM open to every stage. As you may know right now, the duration of this project is quite long, and also BIM models are always used as information carrier across the life cycle of the project. Hence, we have defined the parameters or the information of different kind of stages of the project in the LOI table, in the level of information table. And also in our design stage, we proposed the parameter for the construction stage and for the O&M stage. And we are going to connect those corresponding values with the help of the data collection platform in the construction and O&M stage. Here is another use case about being open to every stage. In our design stage, wet utility was developed in the Series 3D, but we plan to convert it into the Revit for a better geometry development and information management. Hence, with the help of the Dynamo, we convert the information of the pipes, pipe fittings, and the manholes into the Excel file, for example, and then we further turn it into our Revit automatically. Let's have a look of this video. Let's take the pipelines as an example. So with the help of the Dynamo and Excel file, we have been able to transfer those kind of BIM model information from different kind of stages, from the design stage, the civil 3D models, to the construction stage, the Revit models. So according to this video, you can see through our customized tools, we basically achieved the optimized modeling of the pipelines in our Revit environment. The last part is about BIM open to data visualization. So to facilitate the decision-making based on the BIM data, some specific parameters are extracted with the IFC open share. And then those kind of parameters are analyzed in our Power BI. And then those corresponding dashboards are published in the ACC Insights cards. By doing so, we literally bring the BIM data business to every person. This whole video basically shows us the whole process, how we turn those kind of BIM model data into the dashboard so as to be used to the whole stakeholders in our project. Let's take a deeper look at this dashboard. With help of the dashboard, we can first check if all the parameters are following the naming convention, for example, and also we can check if we are missing some parameters. Let's have a close look here. For example, the technical specification parameter, which is defined as a global parameter, which means all those 835 elements are supposed to be configured with such parameter. However, if you see closer, only 834 elements are configured with such parameter, which means one of the elements is missing such parameter. And we also take a closer look of the BOQ parameters. At the very bottom part, you can see 28 of the elements are missing such kind of parameter. So what we are trying to say here, with the help of the BIM open to data visualization, our whole QA/QC procedure, especially from the information perspective, has been improved quite a lot. As we just mentioned, with the published dashboards, we can literally open the BIM to our data visualization and further to every person. I'm going to illustrate the key outcomes as below. First, we have achieved substantial openBIM data metrics. Up to now, almost 2,000 IFC models are created and 40 contractors from 6 countries are involved in our CDE. And over 13,000 BCF issues are created and visualized in our dashboard, and over 100,000 IFC entities with defined attributes are developed. Thus, our 4 openBIM initiatives are realized in our project. And besides, we have achieved well-structured information management. As we all know, the essence of the BIM is about the building information management. Hence, in the BEP developed, we have further developed the well-structured information standard. For example, we have developed the MIDP, the level of geometry, the level of information, and the master production delivery table. And also, following the ISO 19650, the CDE has been established in our project so as to guarantee a smooth flow of such quantity of information. And the next, we have achieved 4 automatic information exchange use cases. They are the efficient information quality check, the seamless information exchange between Civil 3D and Revit, the automatic federating models, and the last, innovative project progress control based on the CDE and plugins. Here, I just want to emphasize a little bit more about the last point. With the help of the data connection platform, we have enhanced the actual progress data and the planned progress data. So by comparing these 2 data, we can literally conduct the project progress analysis and hence the project progress control. The last part, we also have achieved quite a lot quite a lot of quantifiable BIM values with the help of the openBIM. For example, we have achieved the increased relation with our clients, which is quite important, not only for me, I think for everyone. And also, we have cultivated quite good BIM culture in the whole project. And also, we have achieved the increased efficiency, and also we have achieved the enhanced quality control. The last, we have achieved the positive environment impact. As we always say, the last but not the least. So I'm just going to emphasize a little bit more for the last points. With the help of the openBIM, and more specifically with the help of the GBXML file, we have achieved quite a lot in the sustainability study. For example, we have achieved the reduced life cycle cost, the reduced environment cost, and also we have obtained sustainability certificate back home in Bogotá. Here comes to the last part about the participants and contact information. Empresa Metro de Bogotá, the appointing party is our client, and China Harbour from China Communication Construction Company, the concessionaire, is the lead appointed party. As for those major appointed party related to BIM, it include WSP, Zhixing, UCD, and ENG. I know today the time is quite short or limited. You may still have time to have questions for me. So please feel free to contact me. Here is our contact information. Just feel free to contact us. And that's it. Thank you.
Thank you very much. If I could ask you to remain on the stage there for the questions, and if I could invite back to the stage Guangdong Airport Authority and PORR Romania, please. I think there are 2 microphones up there, so we may have to pass them around if that's all right, please. And I believe Ken is ready with the first question.
Thank you for the great presentation, and then I amazed your efforts, and then your finalist here. So I appreciate your attendance. And my question here is our first infra project about the airport. And then there's the CDE, but you named it the Construction Management Platform, CMP. And then the other system, the centralized to CMP. But how do you develop CMP? Did you expand some vendor software or develop by scratch? That's the question.
Yeah. Actually, I understand the question, but for my presentation, maybe I would need to use Chinese, and I will have an interpreter to translate my words. Is that works? Probably for the city construction, we you actually IFC files. It works in our city yeah. Okay, I will use Chinese. Sorry. 在我们的 CDE 建设中，然后我们会用到很多基础数据。
We're going to use the basic data from when we do the construction.
Especially 尤其是就 IFC 的数据支撑，还有很多基于 IFC 数据解析出来的很多软件应用的相关数据，最终是由数据流向我们的 CDE。Actually, we extract some data from the application software. All the softwares, as we summarize in our PowerPoints, we have established our local BSDD. So, firstly, for the application software, we will deliver our information requirements to the application software. So, by doing this with IDS, so we can extract the perfect information we need from application software. This is for application software. Actually, we have many softwares. So for some fabrication software, it also works. And I think this is what we work in our construction management platform. And actually, we have some management workflow. Yeah, this is as we are both from Guangdong Airport Authority. So for our management process, we must personalize. And this is how we work with IFC files. IFC file will provide some stable and consistent information. And we extract it directly from IFC format from BSDD. For the personalized fields, we needed to extend, but we still found that we can have a good we can find a good relationship by IFC, such as IFC real assign exaggerated, and this is how we work with our common data environment.
Okay, thank you.
Thank you.
Next question, do you have one?
I can direct. Thank you for your presentation. Well, really interesting. I would like to also ask question directly to the airport. What was the reason that you created separate BSDD and not use the existing one? I know that you mentioned that it should be improved in some case, but will be plan to use BSDD as it is. I mean, like the service of buildingSMART International, especially use a Chinese version, because you have this IFC translation framework, so you will be able to provide the translation for your engineers and architects and everyone so who is involved. Thank you.
I cannot say we are not using BSDD, but actually in China, for the implementation segments, most of the workers, designers, they are more confident to use Chinese for the implementation language. So actually we need to do a lot of translations from the good resources in BSDD. But during this period, when we translate the BSDD, some of the information may not be in a good one-by-one relationship with our translated Chinese inventions. So this is the reason we need to establish a local BSDD. Actually, our local BSDD works as the ITS checking in our common data environments. And another reason for us we cannot directly use the BSDD API is because we need to because the confidentiality requirements of the airport domain, we needed to we cannot make our location, some information such as the location public. This is the reason we cannot just directly use BSDD.
Yeah. All right.
Our
Thank
BSDD is based, all in all, our data dictionary is based on BSDD.
Thank you. Let's have a question for one of the other projects, please.
Thank you all for the presentation. To the team 3, the Metro Line Bogotá. You explained you have 3 persons for the BIM management, BIM coordination. Can you explain us a bit how you collaborate with the different parties involved, engineers, contractors, and so on, with these 3 persons?
I'm sorry, you're saying we have 3 processes for the correlation? Okay, I think sorry, I'm not quite sure what exactly you are referring to, but as far as what I'm trying to say, I think in this kind of presentation is that we are, how to say, using a CDE to incorporate the whole different kind of contractor stakeholders in our CDE. This is what I thought. I'm not sure to double confirm the question.
That means you have 3 persons, and how many people were involved in total?
Okay. First, I'm going to explain. Like, actually, in our CDE, we have like 40 contractors and from 6 countries. I think right now, more than almost 1,000 people, including our contractors, included in our CDE. For us, we are doing the CDE. We are not using the CDE only as a information sharing platform. But for us, CDE is more like a dynamic environment for us. Except from those kind of basic ISO 19650, we are following the work in progress, we are following the shells and the publish this kind of procedure. What we are trying to do more, because we have such quantity of information, so we are trying to develop a lot of like scripts so that we can achieve the automatic, for example, as we just mentioned, the federated models, and those kind of federated models are going to be published in the shared folder. So all those kind of contractors, they are going to have this kind of accessibility to review, but not to download, to review, but not to edit, not to upload. To download, no problem. For them to have those kind of accessibility to the most up-to-date integrated information. I'm not sure if my team, you want to add a little bit more.
Yes, I think that for CDE, not only for the information sharing, but also for the data collection. Just as mentioned and as presented by Simon, for our subcontractors, they need to report the site progress data to our data collection platform. And all the data will be synchronized back to Revit, and then synchronized and published to ACC again, to let all of our stakeholders to monitor our actual progress on site. And another point is that for our management team, they are also able to use our CDE for decision making by publishing our Power BI dashboard to ACC again.
Thanks.
Thank you.
Okay, yeah, thank you. Last question to PORR Romania. If we have any? Any questions? You have one?
So just, we don't have much time, but just comment. I'm quite interested in the phase planning and then site progress monitoring. And then it's, you used a very good process, and then P6 and generate CSV and add the IFC4, and then the mixture with the Blender BIM. So how do you get those the solution? Do you have any idea from some site or some colleague or community?
So basically, our plan was, okay, we take the P6 schedule, we put it in the IFC, and then we have the plant. We consider that a use case. And we also have site progress monitoring, which is another use case. But what we will do next, the next plan, is to take the actual dates that are in Excel and via the same approach with IFC OpenShell to put also the actuals within the IFC. So you would have not only the plan, but the actuals also. That is our plan, because at the end of the project, we want to have a IFC 4x3 complete execution model in order to archive the project.
Thank you very much to all of the presenters in the two categories we just heard from. We will wrap things up there, and we will now go as a jury and deliberate to determine the winners. Hope to see you at the ceremony this evening. I expect many people are registered for that at the dinner. And please do stay for the next session, where we will hear from the categories of facilities management, handover, and technology. Thank you very much.
Thank you.